Chapter 11, Problem 85 from the textbook. We have 4 ice cubes at 0 degrees Celsius with a mass of 53.5 grams, and they're combined with 115 grams of water at 75 degrees Celsius in an insulated container. So first off, this insulated container means that there's no heat gained or lost to surroundings, right? And it says it right there too. Question is, what's the final temperature? Okay, so what do we have here? I have 150 grams of water at 75, and we have 0 degrees Celsius ice at 53.5. Alright, so I have ice, and I'll use ice as green, and we have water here. And the heat from the ice, right, this is a heat transfer problem. So ice and water, so the heat from the water is going to go to the ice. So that's technically a negative. So if we were to put Q here, Q of ice, Q of water. So now what's physically happening here? Ice is going to melt and it's going to warm up, right? And water is going to cool. If I had a beaker, and I have my water, so here's my, I hit the erase button. Here's my water in the beaker. Wonderful. We're going to throw some ice. 4 cubes. 1, 2, 3, and the 4th one's in the back. Perfect. Okay, so my water is at 75 degrees Celsius, and it's going to cool down to a lower temperature. The ice is probably going to melt and probably warm up. Alright, that's what I'm assuming. Alright. Now, we'll find out if that's true or not. Okay, because our answer it'll work out. So, we have a formula for melting. Delta HF times the amount. And we have a formula for warming. MC delta T. And we have a formula for cooling. MC delta T. Now, because I'm doing it this way, delta T, technically speaking, is T final minus T initial. Alright? So I'm going to rewrite these a little bit more information. So I have delta HF times the mass of ice plus the mass of ice. Now it's liquid water, specific heat of water. And delta T ice is going to equal negative the mass of water, specific heat of the water, and delta T of the water. Alright, so the delta T's are different, the M's are different, the C's, specific heat of water, is the same, and delta HF. Now, we have to look some things up here, I believe. Now, I believe it gives you delta H of fusion is 6. So on the online homework, it gives you delta HF 6.02 kilojoules per mole, and it gives you C is 4.18. grams per degree Celsius. There should be make that clear. Grams per degree Celsius. There we go. Okay, so now we got some constants. Alright, I have delta HF, which is 6.02. Now it's kilojoules per mole. We have grams, and everything else is going to be in joules. This will be in joules, this will be in joules. But I'm just going to put it down. 6.02 kilojoules mole we have 53.5 grams, 53.5 grams, 4.18 joules per gram degrees Celsius, and delta T would be the final temperature minus the initial temperature of 0. Ice is always at 0, right, if it's in water. We don't know TF, the final temperature. Equals negative, the mass of the liquid water was 115 grams, 4.18 joules per gram degrees Celsius. Final minus the initial, and that initial was 75. Okay, and so as you can see, we have some unit converting to do here. All right, with the delta HF. Now, I'm going to do a little side note here. I'm going to do 6.02 kilo times 10 to the third joules per mole times, we know 1 mole of H2O is 18.02 grams of H2O, and we're multiplying by 53.5 grams of H2O. Right? So I just use the molar mass of water, and if I do this, 6.02 times 10 to the third times 53.5 divided by 18.02, or you could divide by 18.02 times, I get 17,873 basically. So I'm just going to write that down here. 17,873 joules plus, now we have to do that first, and then times TF, and then times 0. Well, times 0 is nice. So we get 53.5 times 4.18, and I get 223.63. I'm just going to keep that down. 223.63. Grams is gone. Units, I'll make them pink. Joules per degrees Celsius times TF equals, so I'll make this one pink too. Right, now I have to do, again, I have to do this first and then distribute, right? So 115 times 4.18 is 480.7. So that gives me negative 480.7 joules per degree Celsius times TF. Then that's going to be plus, right, 115 times 4.14 times 75, which is 36052.5 joules. Alright, so add 480 to both sides. So we're going to add 480 to both sides. We're going to move this over, add 480.7 joules per degree Celsius TF to both sides, and subtract 17,873. So minus 17.873 first. I get, oh, nope, didn't work out that way. So 36052.5 minus 17,873. I get basically 180, let's call it, joules per degree Celsius equals, now I use 223.63 plus 480.7, 704.33, so 704. And that's, oh, I messed up here. That's just joules. It's joules per degree Celsius here. And then times TF. Divide 18,180. Divide 704. I get 25.8, or I think we only have 2 sig figs, right? And we'll use 2 sig figs. Right, so I get TF to be 26 degrees Celsius. So what do? We figured out what was happening physically first. Right, so the first thing we did was, undo. First thing we did was this right here. Right, what's going on? Ice is going into the water, and the water is going to cool. So then we set them equal to each other, the ice and the water, my two systems. Figured out what the ice was going to do. Then we figured out the water was going to do. Came up with the formulas of each. Right? And then we plugged in our constants. We had to do a conversion, because your author loves making you do conversions for this Tro book. Alright, and we just did some algebra and got an answer. That's all it is. Alright, so again, the hard part is right there. Once that's done, it's just an algebra problem. Hopefully that helps you guys for Chapter 11, number 85.